Hello friends, welcome to my channel. Today I am going to show you how to interface a gas sensor, which is basically a semiconductor SNO2 based gas sensor, can be interfaced with the Arduino. This is a gas sensor module MQ2 sensor, which is sensitive to LPG, smoke and methane. This is the sensitivity adjustment probes. You can increase the sensitivity by moving clockwise and decrease by moving anti-clockwise. And this is the signal conditioning circuit for the particular gas sensor, and these are the output pins. This is the VCC where you have to need to provide the plus 5 volt. Here is the ground terminal, this is D0, and that is the A0 terminal. Here we are going to use the A0 terminal. First we are going to provide plus 5 volt to the VCC pin. Then we are providing ground to this the ground pin. Basically we should use red as a positive and black as a negative. So we need another connection, that is the output pin. We are going to use with microcontroller, so you will be using the analog output pin A0. So the white color is the A0 pin of the particular gas sensor. Now let's interface or connect with the board. The red color wire we should connect to the plus 5 volt of the Arduino, which is the fourth pin. Then we should connect the ground terminal. We can connect pin number either pin number 2 or 3, and we are going to interface with the A0 pin, analog input pin A0, with the microcontroller board. So as you powered on, you can see this, the LED is glowing, that means the gas sensor module is powered on. This is a buzzer. We have used the buzzer parallel with the LED. Red color positive wire connected to the anode and negative is connected to the cathode terminal of the LED. Now we will connect it. Anode should be connected to the pin number 13 of the Arduino, and cathode should connect it to the ground, which is the adjacent of the pin number 13. So as you can see, we have connected the anode to the pin number 13 and cathode terminal to the ground terminal, and make sure that these two pins should not get shorted. So connection should be done carefully. So this is all about the physical connection. The physical connection is already over. Now we have to go to the computer terminal. The USB port is connected to the computer terminal. Now let's start the program. You can see the program in the setup section. We have set the baud rate to 9600, that is a serial data transfer data rate. And as we have connected the buzzer to pin number 13, so we are making pin number 13 as an output pin. If you use other pins, you can set according to that. Then we come to the loop functions. Here actually we are using a function that is called analog read function. What does it do? It reads the analog voltage from pin number A0 and store the variable or the value to that particular sensor variable. As you can see, we have connected to the A0 the sensor output, that's why we have given A0 at the analog input rate. So the value will be stored into the sensor value pin, and finally you can print the sensor value to the terminal. As you can see, you can go to the port, you have to select the port, and just if you dump the program now, what you can see, that let's see. So we are dumping the program now. As you can see, the program is uploaded already in the microcontroller board. Now you go to the serial terminal of the Arduino. We have made delay 100 millisecond to have a distinguished monitoring. So as you can see, some values we are getting, and this values keep on decreasing slowly. So it will be settled down for a long time. So now we can test the sensor with some input gas. So we take the sensor, and what we do, we will use the marker. As you know, in the marker some form of alcohol will be there which is sensitive to the gas sensor. So just consider the values when now it is near about 165 or 60, 160, 59. When I bring the marker pen near to this gas sensor, you can see the value will start increasing rapidly. So as I am bringing the marker, as you see, start from 161, it will jump to it suddenly increases to the 190, 200 also, 230 also. And if I remove this marker, now it will start decreasing again. But this decreasing will be little bit slower than the input. So it is now decreasing slowly. So as by seeing this, you can understand the sensor is working and the value keeps on decreasing again. So this is the way the sensor is working. So now let's go to the program again, and now we write one loop, because whenever the threshold value gets beyond the particular value, alarm should trigger. So as you have seen, the threshold value is near about 160 or 165. So we are making a condition, if sensor value is greater than, we are making at a 170. So whenever it goes beyond the 170, the alarm should trigger. So that what do we write? We write basically we are making the particular pin number 13 high, because we have connected the buzzer to pin number 13, and we are making pin number high, and we are omitting this negative delay from this. So we are omitting the negative delay or cancelling out the negative delay. So whenever that gas sensor value will become more than 170, the buzzer will start giving the alarm, and LED also give the alarm. So let's dump the program to the microcontroller boards. Now we are dumping the program. As you can see, now program is already dumped. Now let's check it. Now again we will repeat the same procedure. We will go to the serial monitor first, and we will see what is the initial value we are getting. That should be below 170. So yes, you can see the value will be less than 170. So let's check again. So see the value is it is near about 150, 149, 150. It is which is beyond the below the threshold level, which is 170, which we have fixed. Now what we will do? We will insert the gas. That means we will bring the marker near to the gas sensor, and you will see whether the alarm is triggering or not at once when it reaches beyond the 170. Now see the value is start increasing from 140 to 150, 155. Then it is also going 160, 165, and alarm should trigger now at 170. See, now alarm is triggering at 170 and LED also blinking. So it proves that again. See, now it's off because it goes below the 170. Whenever the value goes beyond 170, the alarm starts, and whenever the value goes below 170, alarm stops. So this is the way how we can use that threshold value. We have to set depending upon the initial value of the particular sensor. So as you can see, it is coming near about 150. So we have to set always the threshold value little bit higher than initial value. So if you are getting a false triggering, please see what is the initial value we are getting in the serial monitor, and you should set this threshold value beyond, little bit beyond or above the initial value what you are getting in the serial monitor. So hope you have enjoyed the video. Thank you for watching.